work. I'm trying to record off of one piece of out while talking through this while using the other computer. So, well, it should work. Okay, this is our review. Let's go for it. Okay, a week from today, September the 28th. I'll mention it again on Thursday, and I'll mention it again on Tuesday. MCOM 281. MediaCom, let's see, that's right there, I think, right? Right behind or right north of the architecture building. I think that's the big lecture hall, 281 is. Okay, so we'll have plenty of room. From 6:30 to 8:30 is when we have it scheduled. So that's when we'll run the exam. Bring a laptop. You have to have a laptop. If you don't, you need to talk to us. We need to hustle. We need to. Yes, sir. Okay. I got two different mics on. How about now? Better? Okay. If I drift, let me know, because I have a tendency to do that, as Vivi and Natalie have pointed out. Okay. So anyway, so make sure you have a laptop and that it's running the Blackboard lockout browser. Okay. You need to download that Respondus lockout browser before class. I'm going to put up a test exam. You need to take that test exam. Okay. It will be about 10 questions long, but it'll also test whether your lockout browser is working properly and familiarize yourself with that. Okay. Here I'm going to flip. And we should be looking at, yeah. So if you go to our class, the exam will be sitting down here on the bottom when we start the class. But what you will do is if you go into exam review slides videos, okay, right up at the top, I put a link to the Respondus Blackboard lockout browser. Okay, lockdown browser. So if you don't already have it on your computer, this is how this will take you to here, and it's download the Respondus. You have to download it through this link. Okay, you have to download it through this link. Okay, you can't just go directly to Respondus and get it, because they have to know that Texas Tech bought it so that you can use it. Okay, so you have to go through this link right here. And then there's a little guide. My recommendation is read the guide, go through the steps, read it again if it doesn't work. Okay, if at first it doesn't, if first you don't succeed, read the directions. Right. So after you've tried to do it and it doesn't work, then go back and read the directions. Okay. But let us know that you've got to have a problem. That means you need to test it, not Wednesday, probably not even Tuesday, but at least by Monday. Okay? You need to have tested it and know that you've got it working. Okay? Yes, ma'am.
When are you going to post
Tomorrow morning.
the test?
The little short kind of example test tomorrow morning. I'm putting it together right now. I just didn't get it done before class, okay, before tonight. So I should have that up tomorrow morning. Let's see, any more we need to talk about Blackboard. Okay. Of course, if you go to Blackboard and you go into that same location, into the exams, you'll see I updated the slides. They are a little different. Like I said, probably 90% the same, but there it says 2022, September 21st, right? So, exam over review slides, okay? And then if this actually turns out to record, then there'll be a recording of this. So Whether you want to watch it again or not, I don't know, but maybe at double speed or something, you know. Okay. Now let's see if it'll go back. Okay. So 4x6 card. You can have one 4x6 note card. Okay. That should be the only thing besides your laptop on the desk. You know, everything else should be in a backpack or underneath purse or whatever underneath. Okay. One 4x6 cards. There's some stipulations. Everything on that card has to be handwritten. Okay. No going into Microsoft Word, typing everything up, printing it out in a 4x6 format at 0.4 pica, okay, and then pasting that on the card. Can't do that. It's got to be handwritten. You can draw diagrams, you can draw sketches, whatever you want to put on that card, it's fine with me. Okay, both sides are legal. 4x6 though, not 5x7. Okay, there are other card sizes. Make sure it's 4x6. If you don't have access to a card, then get a piece of paper, use your rulers, measure out 4x6, cut the piece of paper down. Do not fold it down. Cut it to the size. Okay, is that clear? Okay. Questions will be primarily, as it says here, questions will be primarily multiple choice and fill in the blank. Okay, I would say more fill in the blank than multiple choice, actually. And you're going to kind of somewhat see some samples, and then you'll see some samples in the sample test that I'll post tomorrow. Okay. Mainly review the slides. If it's in this presentation, it could be on the exam. Okay. If I discuss it in this presentation, if it's in these set of slides, it could be on the exam. Okay. Anything that's not discussed in this review will not be on the exam. Okay. So you don't really have to worry, but these review slides include a whole lot of stuff. Okay. Probably 90% of what I've talked about in class. Okay. 80% maybe. So, one thing that I've found is that, you know, I like to give people that 4x6 card, okay? But I found that some people lean too heavily on it, thinking that they can write everything down, you know, and they don't really have to learn it, okay? The problem with that is that you will not finish the exam in 2 hours if you have to go back to that card and look for every answer, okay? Even if you've got them all written down there. There's just, it's a timed exam. It's 2 hours long. There's 100 questions or 100 answers, not 100 questions. Okay? So you got about a minute. You need to know the card should be, you know, a little bump, right? Oh man, I know that word. Oh yeah, that's it. Okay. Did I spell that right or something like that? Okay. So don't use it as a crutch for not studying the material and knowing the material to begin with. Okay? It should be a help. And actually, filling it out will be a help study-wise. Okay? Because you'll start prioritizing what's most important and to be able to get it all on that card. Okay. So, wait. Okay. Design process. What are the 6 cognitive stages? Okay, you need to know what those are. You need to know what the 3 of design are, right? Goals, plans, actions. What the 4 programming ones: beliefs, values, needs, goals. Okay, you need to know what those mean. Okay, if I try to match up, do a match with goals in a, you know, and I give you a list or a multiple choice, and what's the definition of goals, you need to be able to know what that is. Okay. When we transform goals into plans, we use synthesis to build relationships to develop concepts. Okay? You need to know and understand that statement. Okay? It's on the exam in some form. I can guarantee you. Okay? You need to understand the meaning of synthesis. You need to understand the meaning of concepts. Okay? And what are the four primary stakeholders? Four primary stakeholders. It's up there. read them off. Somebody.
Designers, clients, users, instructors.
Yeah. Designers, clients, users, instructors. Okay? Will be on the exam. Okay? Value spheres. Okay? The four value spheres. Know what they are. Right? Aesthetics, technological, social, and the cultural. Okay? Know what those are. Know what they mean. What they're referring to. You'll have to go back to your slides to get those definitions. I didn't write them up there. Okay? You'll have to go into the presentation slides, my lecture slides, to get those answers. And that's really all you need to know about that. Okay? Feel free to ask questions anytime. Okay? If I can't or I'm unwilling to answer it, I'll tell you. But don't just stop me and say, I got a question about that. I got a question about that. Okay? So feel free to stop me and get your questions answered. Okay. Unfortunately, this thing's so small. So what two site conditions will have the most impact on the design of the foundation of a building? Soil and soil mechanics. Okay. Know what the definition of soil is and what the definition of soil mechanics are. How they differ. Okay. They're not the same thing. Okay. They're two different things. What site condition will have the primary lateral force on the design of the structure and envelope subsystem of a building? And of course, that's wind. That's the primary lateral source that we have acting on all buildings, the primary one. There's others, but that's the primary one. Rules most design. Okay? And then name two site conditions which have an impact on the design of the interior subsystem. It may not be just the interior subsystem, okay? I may ask for envelope, as you see in that next question, okay? Usually what I'll do is have a multiple choice question, and it'll say select all those that have an impact on this, okay? So you're prompted to a certain degree, okay? Oops. Okay, what are the four major subsystems of a building system? Well, first of all, what's a building system? Name a building system. Light wood framing, maybe? Okay. The one we've been talking about for about 3 days. Okay. Light wood framing is a building system. Okay. Underneath that, there are four subsystems. What are those four subsystems? Did I remember? What? Speak up. Footings. No, but you're close. Okay. Structure, right? Structure, envelope. The structure, what holds the building up, what encloses the building. Okay. Now, what are footings a part of? They're actually an assembly underneath foundation, okay, which is underneath structure. Okay. And all buildings are kind of, this hierarchy exists in every building, okay? If you'll kind of get a feel for that, then I think you'll start to better understand how buildings are built and how they're put together, okay? Because they're very hierarchical in nature. Okay? So we have structure, envelope, mechanical, which we're not going to cover, and then interior subsystems. Okay? Those are the four main subsystems. Yes, I will. Structure, mechanical, envelope, and interiors. Okay? What are the major differences in how uniform loads are distributed across a frame structure and a plate structure? Okay? What's a frame structure? What's a frame? What two components exist in a frame? Could you draw a diagram of it? What two components are there in a frame? No, two frames make a bay, right? Two frames make a bay. Two columns, right? And a beam. That's a frame, okay? What's a plate? It's a flat structural system, okay? It's a continuous, and it carries loads in two directions, okay? Along both axes of that plate. Okay? The frame carries a load where? When a uniform, think about the diagram. When a uniform load strikes that beam, what happens to it? What happens to the load in the frame? It's carried out, right, to the columns, and then the columns have to go to ground, right? Somehow that weight, that load has to get to ground. Okay? With a plate, okay, a plate, it just distributes in four directions, not just along a linear direction like a beam, okay? A plate, the loads are in four directions, okay? It's got two axes of distribution. What are the three structural means of establishing lateral stability? Lateral stability. Wind blowing on the building. What are the three ways structurally that we neutralize that? We mediate it. Huh? I'm sorry, you're going to have to speak up. Rigid frames, a braced frame, in other words, we brace it, right? We triangulate the corners so that we get a bracing in there. And then what's the third one? What's the third one? And shear walls. Okay. So those are the three ways we can that are the most common ways of laterally. There are others, but they're rarely used, only in special conditions. Those are the three most important. Okay. What determines the construction type rating of a building system? The rating of a building type, a construction type, the Uniform Building Code. Okay. It rates building different construction systems. Several of them, well, all of them we're going to cover, okay, in this class. Well, there are two major categories of loads for the building: static and dynamic. Okay? Those are the two major categories: static loads and dynamic loads. What's the difference between a dynamic load and a static load? Pardon me? Right. Okay. Wind, earthquakes, right? Those are dynamic loads. They're also change over time. Okay. In other words, a wind might be blowing at 40 miles an hour, and then it drops down to 20 miles an hour, and then to 8 miles an hour, and then it goes back up. And you go through the eye of a hurricane, and all of a sudden you're on the other side of the eye of the hurricane, and now it's 120 miles an hour again. Okay. So that's a dynamic load. Okay. Static loads are what? They remain static, right? They don't change. Mm-hmm. What is the difference between a static load and dynamic? We just talked about that. What are the two primary static loads for most buildings?
Live loads, dead loads.
Yes. Okay. What is the difference between a uniform load and a point load? We have a beam and it's uniform loaded. What does that mean? Evenly distributed. In other words, the same load ideally on every point along that beam. Okay. So then what's a point load? Yeah. All that load at one point on the beam. Okay. And they all affect the beam differently. They both affect the beam differently. Okay. What is the difference between what are the two dynamic loads and define? Well, there are two primary dynamic loads,
Earthquake and wind.
earthquake and wind. And I hope you can define an earthquake and a wind. Okay, what wind is. You may be asked to draw a sketch diagram which describes any of these conditions. Okay. Example, diagram the impact of a uniform load and a point load or a point load on a frame. Okay. Forget that. It's not on the exam. Forget that last one. I don't have a question on it. So. Yeah, that last one there, don't worry about it. Okay. Once again, the building system hierarchy. At the top is the building system itself. Light wood framing, we're going to look at steel framing, we're going to look at concrete framing. Okay. Below that are the four subsystems. Right there. And then underneath that, you can see are assemblies. And under structures, which is what we've been going over, is foundation, okay? Structural frame, either possibly load-bearing walls, roof, and floors, okay? Those are the main assemblies underneath structure. Okay? If we go to then, and we look at structure, okay, then we have a subsystem called structure. We have an assembly called, let's just go with foundation since it's here at the top. And then foundation has sub-assemblies, okay? It may have a spread footing. It may have a concrete pier. It may have a continuous footing. It may have stem walls, okay? Those are different sub-assemblies to a foundation. It may not have all of those. It may only have one of them, okay? And then if you look at, say, spread footing, and then you've got components, and there's two components. There's a steel cage or steel that is arranged inside that footing, that spread footing, and then there's the concrete itself, or the footing, what we refer to primarily as the physical footing. And the material is steel. You make the steel cage out of steel, and you make the footing out of concrete. Okay, wood. What's the difference between hardwoods and softwoods?
Hardwoods are meant for furniture use mostly. Plywoodwoods are going to be used for construction.
Okay. That is a use difference. What is the difference between them as far as wood? Yeah, as the picture shows, okay? You got pine over here, which is a softwood, right? Oak over here, which is a hardwood. Notice the grain and how much finer it is, okay, in oak than in pine or fir or any of those softwoods, okay? So the grain is finer, okay? It's usually denser, and therefore, usually, hardwoods are denser than softwoods, okay? That means they're harder, okay? That's the reason they're preferable for furniture, because if you hit maple or, okay, oak, you're not going to leave a dent in it, okay? If you've got pine there and you drop something on it, you're going to have a pretty major dent in it, okay? Because it's just not very dense. It doesn't react real well. But because it isn't dense and still has good strength, and it's great for structure, creating structure, because it's very nailable. Oak, maple, those types of woods, those hardwoods aren't real nailable, okay? They'll split really easily because the grain is so fine and they're so dense. The other differences you can tell between softwood and a hardwood is hardwoods are deciduous. What's that mean? What's deciduous mean? 8th grade science. What's a deciduous tree versus a conifer tree? Pardon me? Yeah, well, leaves versus leaves. What happens to an oak in the winter? Loses its leaves. Okay? What happens to a pine tree in the winter? It doesn't lose its leaves. Okay? Deciduous means it loses leaves. Okay? During winter, it goes in stasis. Okay? Pine trees, softwoods don't do that. Okay? They also propagate by conifers, some kind of cone or a nut sometimes. Okay? They put out seeds. Okay. Getting wood to lumber or timber, okay, to lumber. Timber is just logs, right? And lumber has been worked in some way to make it useful, more useful for us. How does the way timber is sawn impact the wood? As it says up here, it determines the appearance and direction of the grain, right? So how we cut the wood will make the grain run a certain direction. That can be important in a couple of different ways, okay? One is aesthetics. We may want a grain that looks a certain way. The other is it's stronger. The grain is sometimes stronger in certain directions than others, okay? Surfacing. What are the different surfacing designations and what do they mean? Rough, of course, is just unsurfaced lumber. Rough, unsurfaced lumber. S2S is what? S3S is what? What does that mean? Pardon me? Yeah, surface 3 sides, surface 4 sides. Most of the lumber that you see in Home Depot is all surface 4 sides. Okay, it's been planed down on all 4 sides. Okay? Moisture removal. The 2 methods of removing moisture. Right? As it says up there, kiln drying, okay, and air drying. Which is the better method? Or makes the wood stronger, keeps it from shrinking? Huh? Kiln. Okay. That's why it's so much preferable to have kiln dried wood rather than air dried wood. Because the moisture levels are a lot less. Okay. How does moisture impact the quality of the wood? Increased strength, reduces weight, controls shrinkage, kills infestations, hardens pitch, and preserves color. Okay. So if we remove that moisture, we can improve all those kinds of things in the wood. Okay. Lumber grading. What factors determine the grading of the structural lumber? Appearance, species, strength, moisture content. Okay. That's what its grading is based on. Appearances, only lumber grades are used for what types of lumber? So an appearance lumber grade is only used for hardwoods. Okay. Appearance only. In other words, a grading. So we're looking at the flawlessness of the wood, whether it's got knots or not. Okay. That's an appearance grading, whether it's checked. What's nominal versus actual dimensions?
2 by 4.
Okay, so which one's nominal and which one's actual?
Nominal is the 2x4, sir. Actual dimensions is
Yeah.
1.5 by 3.5.
Right. Okay. So a 2x4 is actually the dimension of the piece of lumber before it's been processed. Okay? Before it's been surfaced and before it's been dried. When it's dried, it shrinks, and then when they surface, they're taking some of it off, and so the result is the actual dimensions, okay? Which are less than the generic 2x4, which are called nominal dimensions. You really need to know that. That's going to be on the test, the difference between nominal and actual. Lumber strength is the working strength and tension better than the lumber or concrete. And of course, in tension, lumber outperforms concrete any day of the week per volume. Okay? Because concrete just doesn't have any tensile strength until you put what in it? What do you have to put in concrete? Rebar, steel. Okay? Some kind of steel. Okay? To take those tensile loads. Veneers. How do the different cutting procedure in the veneer impact the veneer? The appearance of the grain and the directions and pattern. Okay. And there's the 4 different methods of cutting. Rotary cut, quarter cut, a rift cut, and a plane sliced. Composite lumber. Glue laminated lumber. Glue laminated lumber improves what qualities of the wood timber construction? Well, it's right there, right? By laminating different pieces of lumber together into a glue laminated piece, we can span greater distance than we could with the same dimensional size of just pure lumber, okay? We can shape it into form, into different forms. We can make curved beams really easily. Not really easy, but easier, okay? And it has greater strength and stiffness. That's the reason we can span greater distances. Cross-laminated timber, okay? That's where we take lumber, right? And we run the boards cross to each other, and then we glue them together. So each board's turned 90 degrees on the next layer. So we have up to 3 layers, maybe as many as 7 layers of dimensional lumber. Okay. So it's like taking 2x4s, creating a plane of 2x4s, and then rotating 90 degrees, creating another plane of 2x4s, rotating it, another plane of 2x4s, and then pressing and gluing all those together. Okay. It's like really thick plywood. Okay. Similar processes to plywood. Okay. Composite lumber. Okay. A group called composite lumber. There's 3 types: OSL, LSL, and PSL. Okay. Those all involve the orientation of what? Yeah, no, they don't do that. They're not crossed. Well, there's some of them are. It depends on which one you're talking about. But one thing they all have in common is they're made out of wood strands, right? Strands of wood, thin strands of wood, okay, that are oriented. In other words, they're oriented in a certain direction. In the case of lumber, they're usually oriented along the length, okay? They're oriented towards the length, and then they're compressed together and glued, okay? What is the primary difference between the 3 forms of composite lumber? It's the width to length ratio of the wood strands, okay? So they have these strands, and it's the width to length, okay, ratio. The longer the length, okay, of strand, the more strength in the wood, okay? PSL has the highest length to width ratio, okay? LSL has a little smaller, and OSL has the smallest, okay? So they're from top to bottom OSL, LSL, and PSL. PSL is the strongest. It's the only oriented strand lumber that actually can be used for structure. Okay? The others are used for non-structural conditions, to make doors with, to make a variety of things, shelving, a variety of things. Which of these has greater strength? PSL. Okay? What is the general structural usage for the different forms of lumber? Light wood framing. Okay. And then there's laminated veneer lumber, which is even stronger than any of these. And that's basically plywood, okay, made into the dimensions of a 2x4, okay, because it's a series of veneers that they've glued together, okay, and then they've cut it into that shape. Okay. So that's what LVL is. Laminated veneer lumber. Once again, they cut a whole series of veneers and glue them together, versus oriented strand, versus a series of strands. Okay? Structural wood panels. Okay, there's two basic products in there that we use a lot. One is plywood, and one is oriented strand board. Okay, how is plywood produced? By cross-laminating a series of layers of veneer wood into a wood panel. So what they do is they cut a veneer, and the grain runs this direction. They cut another piece of veneer, and they rotate that 90 degrees. They cross-laminate it. Okay, and then they cut another piece of veneer, and it's turned 90 degrees to the next one. And they keep doing that till they have the appropriate number of layers, okay, to get the thickness they want. Usually 7 or 8 layers at least in a piece of plywood. Okay. So they cross-laminate it, they glue it together, put it under pressure, and that's how plywood is made. Okay. How is it graded? There's 5 different grades, right? A, B, C, D, and then X. Okay. If you're going to use plywood for an exterior condition, what symbol do you have to have on it? The X. Okay. If it says CDX, that means one side is a C side, okay, and one side's a D side, right? And then the X means they've used exterior glue. Okay? So it can be used under wetter conditions, exterior conditions. Okay? In finished plywood, okay, you have what is called A and B. Most finished plywood that's used, and so that outside veneer is usually a high quality wood. Normally a finished wood, which means it's normally hardwood. Hardwood like maple, oak, ash, okay? And it's very clear. A means a very clear piece. B is with some flaws, okay, but minimal. So the most common is an AB for finish. What directions are the strands in OSB? Okay. They're parallel to each other. Okay. The strands are parallel to each other on the exterior layer, on the 2 exterior layers, and then they have a middle layer where they cross it. Okay, so it's also crossed in the middle. What's the difference between particle board and fiber board? Does anybody remember or no? They're very similar. Okay, they're very, very similar. One's a pretty poor product. Particle board is made the same way fiber board is made. It's the difference is in the size of the particles. Okay. The particle board, they're taking sawdust, basically, really fine particles of dust, and they put it into a resin, and then they pressurize it. And now, fiber board is done the same way, except the grain is really, really small, okay? And it becomes really, really dense, and it's really, really hard. It's the primary veneered fiberboard, I would say, is the primary method or material for making cabinets. Okay? Most cabinets, except for the cabinet doors, sometimes they'll be solid wood. Okay, but the boxes that make up the cabinets, they're all going to be MDF. Okay, what do I mean by MDF? Medium density fiberboard. There's low density fiberboard and there's high density fiberboard. Okay. MDF is the most commonly used. This is a composite wood I-joist, right? And there's two components to it. One is the web and the other is the flange. Those two pieces right there are the flange, and this is the web. Okay. The most common material used in that web is OSB. Okay. The flanges are usually an LVL or PSL, parallel strand lumber, or yes, ma'am. It wasn't showing where I was pointing. Oh, it doesn't. No. Okay. This is an I-joist. Okay. This middle portion right here is called the web. Okay. It's made out of OSB. These two top portions are called the flange. Okay. And those two are usually made out of LVL or PSL. Okay. Structural composite boards. Okay. The truss. Can you label or name the components of that truss? Okay. What are the three primary components of any truss? Pardon me? No. You're in kind of the same range, yes ma'am. And webbing, right. Yeah. The top cord, right, that part, the bottom cord, and then the webbing. And of course, then there's metal gussets that connect it, right? So just like this interior piece right here is called the web, okay, of that joist. They use a similar term. They use the same term for the interior members of a joist. Okay. So webbing, right? Bottom cord, top cord. What is the structural advantage of a truss? Lighter weight, greater span. Okay. And what we mean by lighter weight is we're going to use less lumber. Okay. We can use less lumber. What's the major disadvantage of a web? Yeah, there's no really space there. All the space is broken up. It's okay to run ductwork through and stuff like that, but it doesn't create a volume or a space very well, unless you design the truss to do that. You can design trusses to create attic spaces. Okay? But the one thing that some people don't like about it is there's no attic space. What components in a structural system may trusses replace? Okay. They can replace floor joist. Okay. We can use trusses for floor joist instead of 2x8s, 2x6s, instead of lumber. Okay. Or instead of I-beams or I-joist. Okay? And we can replace rafters, right? And ceiling joists, right? Rafters, ceiling joists, we can replace those within a truss. Wood chemical treatments, you just need to know that there are 3 different types and kind of what they do: insect resistance, fiber decay, combustibility. Okay. It's pretty definite. The definition is pretty much in the word, right? How do you know if the lumber has been treated? How do you know if a piece of lumber has been treated for any of those 3? Stamp. If it's not stamped, I don't care what they tell you or what it looks like, you assume it is not treated. Okay? You just assume that it's not treated. Because if it's been treated properly, it will have a stamp on it. And most often it will be burned into the wood. Okay? So it can't be gotten rid of or can't be faked and added on. Though you could make your own brand, I guess. Okay. Nails. What is the term and the symbol used to identify the size of a nail? The term so it's called a 10 what nail when we talk about nails? 10 penny, right? 12 penny, 8 penny, okay? Which is larger, an 8 penny or a 12 penny? Huh? The 12, yeah. Actually there, the numbers relate to the size, okay? So 12 penny, 10 penny, 8 penny. But when it's written out and they write 10, what do they put next to the 10? A D. And they still do it. This was established in Roman times in England. Okay. And they're still doing it this way. A D was a denarius, which was a penny. Okay. They still use the why, I do not know, just because I guess it's deal. What's the difference between a common nail and a finished nail? Yes, ma'am.
Are we going to have to know what the D stands for?
Huh? No. No. But you might have to answer that question that's up there. What is the symbol used to denote a nail? The letter D, right? You don't need to know that it's it's based on a Roman coin, okay? But you need to know if you see 10D, what that D stands for, okay? It stands for penny. Why it isn't 10p, I don't know. Well, I know why, because denarius starts with a D, okay? It doesn't make any sense. But that's the way it is, okay? It's just one of those things, that's the way it is. That makes sense? That answer your question? Okay. Which nail is stronger and longer? 10D, of course. Why is the head of a common nail and the finished nail different? Countersinking. Okay. The common nail, the head is very large, and its intent is when you drive it to grab onto the wood to keep it from being pulled through. Okay. A finished nail has a very small head. And because you come back and you countersink those nails and you cover them up. That's why they're called finish nails, because they're used on the finish, okay? Maybe on a subfascia or on a soffit, any kind of wood that, or lap siding, they'll use a finish nail so they can sink that finish nail and cover it up. Okay? Machine-driven nails, why are they used? They're faster. That's pretty much the only reason, okay? Three primary components of a screw: the head, the shank, and the thread. Okay. When do you use a wood screw? Okay, you use wood screws with a hardwood finish construction. Okay, If you're trying to put two pieces of oak together and you want to screw it, you're going to use a wood screw. Okay? If you're trying to assemble structure, you're going to use what is called a production screw. Okay? It's a different type of screw, bigger threads. Okay? It's not really designed to go through hardwoods. It's designed to go through softwoods. Okay? So there's kind of two different kinds of screws used in construction. One is called production screws. The other is called a wood screw. Okay? When we're dealing with light wood construction. What is the purpose of a pilot hole? Well, as it says up there, the purpose of a pilot hole is you're going into hardwood. Hardwood has a very dense grain. If you don't drill a pilot hole, 9 times out of 10, you're going to split the wood. So it's to give you a beginning, okay, so that you won't split the wood. And just the thread of the screw will bite into the wood. Okay, light wood framing. Could you draw us? Well, you're not going to have to draw them because we're in Blackboard. Usually it's on paper, so I'll have y'all draw diagrams. Now you're just going to pick diagrams. But draw a series of diagrams showing platform framing and label each step. So you need to understand what platform framing is, right? You build a foundation, you build a platform, you stand walls up. You put a platform on top of those walls, and you put walls up. Then you either put a roof, or you keep going until you get to 4 stories. Why a 4-story limit? Huh?
It's like the capacity of light framing, you don't want to go 4 stories.
Not really the capacity. We could go our code. Yeah, okay. They, being the International Building Code, has determined, okay, that is the safest height for light wood framing, okay? So you can't build. Now, if you're outside of any coded district, a district or a place where they don't have codes, then you can go as high as you want, okay?
How do they know?
How do they know? Test it. They test it. Yes, ma'am.
So if we don't have to draw it since it's online, how is it going to be written out?
Well, you'll see that when you see the example questions. Normally, what I'll do is I'll have a diagram, and I'll have you define what the different point. I'll show you some examples of that in just a few minutes. Yeah. Mhm. Okay, so the first step is a foundation, right? And there's 3 types of foundation. Slab on grade, okay, with a continuous footing. What you need to know here are what the major components of that are. You know, this is the footing, right? There's the slab. They may be separate from each other. There may be a joint right here. Doesn't matter. It's still slab, still footing. There'll be some rebar, some steel, and then there's going to be some wire mesh. You can see the wire mesh over here, right? So there's the slab, the footing, the wire mesh, just a second, I'll get to you, the steel, and then a polyethylene shield, okay? So there's 5 components. 5 components of that, okay? Could you label them, okay? If you were given this diagram, could you label them, identify them, okay? Sure, okay? There's the footing, okay? There's the slab. Those are the 2 primary, right? They're made of concrete. Then there's wire mesh that goes in the slab. That's the steel that gives it some tensile strength. Then there's rebar that goes into the footing, which gives it tensile strength, okay? And then there is usually some waterproofing material, polyethylene or something that is used on the ground to keep moisture from being absorbed into the concrete. Okay. So there's 5 different components. The second type of foundation that's used in most light wood framing is footing with a stem wall. Okay. So it looks something like this. There's a footing, right? And then you can see there's some steel in there somewhere. Okay. It has steel in there. And then there's a stem wall, which has some steel in it. Okay. If you make that stem wall long enough or tall enough, it becomes a foundation wall, and it gives you the ability to create a basement or a space in there. And then you might pour a slab. Most pier and beam don't have a slab underneath it. Pier and beam, not pier and beam, I'm sorry. Continuous footing and stem wall. Then the third, this is the one you modeled for A2, right? Footing and a continuous footing and a stem wall. Okay. As well as you added piers with a spread footing. That's the third method. Okay. Later on, you're going to model a slab on grade with a footing. Okay. Those are the 3 most common, okay, the 3 most common foundation systems used in the majority of construction. Okay. So this is pier and beam. So there's a footing that has steel in it. There's a pier. Now this pier might be a variety of things. Okay. In some wood construction, it is wood. They make it out of wood. Okay. Especially in older houses. Most people don't do wood anymore. I wouldn't. Okay. They're either steel or concrete. And in most light wood framing, it's going to be steel. Okay. Because what they're going to use is an adjustable jack. And we didn't get into that specifically. But they use an adjustable jack, and that way it's easy to level. Okay. And of course, then termites can't get to it. Okay. A little bit more expensive, but well worth the investment. Okay. This diagram, can you name every component here? Let's start with the roof. Wait a second. Okay. You should be able to. This specific diagram will be on the test. Yeah. You will have to name each component. It will be on the test. Okay. So, platform, floor, right? There's 3 main components. Okay. There's the seal plate. That's the piece of wood that sits on the foundation. Okay. Usually treated, almost always treated to keep it from rotting. Okay, because it is exposed to a lot of water, and it also has the propensity to absorb moisture from the concrete. Okay, so that seal plate is usually treated lumber to keep it from rotting. And then there's the joists themselves. Okay, you can see them there. Okay, or here in this other diagram. And then the rim board, or a banding joist. Okay. This is usually called the rim joist, though. It's the most common. Okay. They may run between 2x6s and 2x12s in size. They can be 16 inches to 24 inches. They can, in some cases, be 12 inches. Okay. Not very often, but sometimes they do so that they can span a greater distance. They'll reduce the distance between each one to 12 inches. And then I-joist, they can be anywhere from 9 1/4 inches to 24 inches in depth. so they can be fairly deep. Okay, it means they can span, and of course that's an I joist right there. Those here are a series of rafters, joists, not rafters, series of joists. Okay. And then that banding right there, that joist right there is called the rim joist. Okay, because it terminates perpendicular to the other joist. This is just showing a section cut. Okay, this is cutting through a series of joists, right? There's the joist right there, and they're sitting, this one here is sitting on the sill plate. So if we cut it back the other direction, in other words, if we cut the section in the opposite direction, here's the joist here. Here's the rim board. And then there's the sill plate. So those two are just two opposite directions, right, of cutting through that. I hope you got that out of that, building that model. Yes.
Can you please speak up?
Oh, I'm sorry. Okay. Thank you. Okay. Okay. You're going to get this diagram. You need to know these components. That's all I need to say. Okay. You may not be asked for every one of them. I may only ask you for 3 or 4 of them, but you need to know what the components are to a typical light wood frame. Okay. Wall. What's the general spacing between studs on a wall? What are the two most common spacing? Yes, ma'am. 16 and 24 inches. Okay. Here's an example. Here's a wall section, right? And you'll see in your slides, these are actually, the names are there. I blanked over them, okay? So you kind of see, you'll have wall section diagrams like this, okay? And there'll be A up there. What's A pointing to in that wall section? Huh? Anybody want to guess?
Ceiling joists?
Yeah, ceiling joist, okay? Or that, in some places you'll see it referred to as the attic floor joist, if the attic is habitable, okay? But it's a ceiling joist, okay? It's a piece of lumber they'll nail the ceiling to. Okay? What's M up there? Rafter, right? What's B? Huh? Top, it's a double top plate or the top plate, okay? Sometimes it's double, sometimes it isn't, but this is the top plate. In this case, it is double because there's 2 X's there, right? Which means it's 2-dimensional lumber, 2 pieces of dimensional lumber. That's what that X means, okay? It signifies that that's a dimensional piece of lumber, okay? Either a 2x4, 2x6, 2x8, 2x12, but it's a conventional dimensional lumber. What's C pointing to? Huh? Stud. Yep. And D is pointing to? Sole plate, or the bottom plate. Okay. I've got the test set up so that if you put bottom plate in there, it'll give you credit. If you put sole plate in there, it'll give you credit. Okay. Because the old term is sole plate. The new, most people call it the bottom plate now. What's E pointing to? Sheathing, but technically, sheathing is one term. It could be called sheathing. You'll see it places where it's called sheathing. In some places, you'll see it called subfloor, the subfloor. Okay. In other places, you'll see it called floor decking or decking. Okay. I've got the test set up so that if you gave me any one of those three, it'd count it right. Okay. What's F?
Rim joint.
Yeah, that's the rim joist. Okay. And then G is what? If that's the rim joist, what is G? The joist. Right? Okay. So if that's the rim joist, then the joist is running perpendicular to it, right? So we're seeing a surface of it rather than a slice through it. And then H and I and J are the same thing. I didn't cover up subfloor there. What's K? Down at the very bottom. Sill plate. Okay. And what's L? Pardon me?
Foundation.
Yeah, foundation. You could say stem wall. I've got that in there as an acceptable. Okay, if you thought that was a stem wall. Okay. Foundation, though, is a more generic. In other words, that's a foundation, right? Or foundation wall. Floor framing. What is bridging? What's bridging? It's pieces of wood or metal put between joists, okay? Usually in an X form, okay? It could be, you can see two different conditions, one right here, one right up here, okay, where they're using metal in between there, and here where they've put wood in there instead. Most people, because it's faster, they'll use the steel now as the bridging. You can see pieces of wood here, 1x3s or something, 1x4s are being used as bridging there. Okay. And that keeps the joist, when they're really long, from bowing or turning. Because if they turn, then they lose their strength. If we have an opening, and it doesn't matter, an opening in a floor or a ceiling, a roof, either one, okay? There are two, there's the header, that goes perpendicular, that portion of the opening, that member that goes perpendicular to the joist or the rafter, and the trimmer is the one that finishes off, which is in the direction of the trimmer, of the rafter or the joist. Okay? And that's the difference between a header and a trimmer. Okay? Header, perpendicular, trimmer, parallel. Lateral forces. Okay? There's three conditions that come from lateral forces. The primary lateral forces are right, wind and earthquakes. Okay? Those are the two primary. There's a variety of others. Okay? But those are the two primaries ones. If we design for those two conditions, we've pretty much got everything else covered. Okay? Because those can be so extreme. Okay? Earthquake can be really extreme. Okay? And of course, wind, if you're in hurricane country, it can be extremely, okay? So to keep the build from sliding, okay, what we do is we bolt it to the foundation. We basically bolt it to the foundation so that it won't slide off the foundation, okay? Whether it's a slab on grade, pier and beam, in this case, this is a footing with stem walls, right? You can see the stem walls in there, okay? So they bolt it to the foundation. That keeps it from sliding. From overturning, okay? Flipping over, right? To do that, we use what is called hold downs, okay? And hold downs run through the whole wall, all the way from the top to the bottom, okay? And they're bolted down. and that'll keep the building from flipping over. Okay. And then racking, which is the most common. Okay. And we always design and build with a certain amount of racking considered. Okay. The use of hold downs, we always bolt. We may use more bolts, bigger bolts, or whatever, but we always bolt the platform, the floor platform to the foundation, or the wall to the slab on grade. Hold downs, you don't see that used a whole lot except in very extreme condition places like earthquakes, where, like in California, where they have a lot of earthquake conditions. So racking, okay, shear walls and bracing, okay, one of the most common light wood frame structural methods used to account for a lateral, I left a preposition out, account for lateral loads in wall framing, okay, the two most common methods. Yes, ma'am? A shear wall made from, how do you get a shear wall in light wood frame? Huh? Yeah, you sheathe it. You sheathe a wall, a stud wall. You put sheathing on there. When you put sheathing on there, you're now tying all those studs together. You've, in a sense, given it structural stability, okay? And it becomes what we call a shear wall. The other is, I think you said it, didn't you? Bracing, right? The other is just brace, okay? Very few people brace anymore. Primarily because most contractors, especially the good ones, they sheathe the whole house now with OSB. It's just, that's what they do, okay? Used to only sheathe the corners of the building. Okay? Put one 4x8 sheet on each corner. Okay? But OSB has gotten cheap enough and that it makes such a sounder building, they just sheathe the whole building. So now when you go out there in suburbia, you'll see framed with sheathing all the way around, okay? And that resolves that racking. But a common thing to do used to be to use diagonal bracing, okay? And they basically, it's an L-shaped piece of metal. They put a slight cut into the studs, and then they nail it across. And once again, they're triangulating, right? They're creating a triangle of structure. Okay? Because a triangle can't deform unless you change the angle or the length of the legs. Okay, you should be able to label these roof types. There's 6 of them, right? What's the top one? Flat. Okay, what's the next one? Shed or single slope. Sometimes they just say single slope, okay? What's the one below that? C, a gable. Mm-hmm. What's the A here? Hip, okay? What's the B? Gambrel, G-A-M-B-R-E-L, right? Gambrel. Actually, these words are in the slides. I just covered them up for this so that we could take guesses. Okay. Okay. And then the last one, mansard. Okay. Mansard. Okay. And there's 2 different versions you'll see of a mansard. One is this, where there's a pitch, kind of like a gable. It's like a hip gable, if you think about it. Okay. Whereas a hip roof is a hip gable. Those words are very close together. But you'll see that top portion, that second pitch. Sometimes, especially in France, that was so low that it was perceived as being flat. Okay. And you'll see a lot. So the mansard roofs that you see today, in most commercial, people don't do mansards. In the 60s, it's like, in the 70s, it's like everybody fell in love with mansards for some reason. everything. But the mansard roof, okay, and the top part was just literally flat or almost flat. You never have a perfectly flat roof because you got to have it drained. Okay. Okay. This is a cross section through a roof. Okay, for roof framing. What's A? Rafter. What's B? Yeah, what is that pointing to? Looks like it's pointing to the rafter again. Yeah, I think it's pointing to a rafter. Because the other arrow down below it is top plate, right? This arrow here, I don't have a box out beside it, but that's, oh, the bird's mouth. Yeah, yeah. Not that effective, okay? But yeah, the bird's mouth, right? That notch that they put in there so that the rafter sits on top of the wall. Thank you, whoever figured that out. Like I said, the words are in the slides I gave you, so if you've got the slides, you can look it up. What's this member right here called? Huh? Cross tie. Yeah. What is it for? It's for the rafters. What? Yeah. When we want to make that connection, right? When we want to make that connection, we triangulate it, right? We put a member in here, we triangulate it, and now it's stiff. It's stiffer than it would be if we didn't have that. Okay? That cross member keeps that rafter from bending, moving out. Yes, ma'am.
Is it a collar tie or a cross tie? Or does it matter?
You're right. I'll take both. But I think the comment is collar. Is that what it says in the slide? Okay, collar tie. Okay. Mm. And then what's E or F pointing to? Yeah, the ridge board. Okay. See, y'all are going to do well on this test. Mm-hmm. What is this right here? Where two roofs come together, where two pitched roofs come together. What's that called? The valley. Okay, it's called the valley. And there's kind of two framing components to that. You can see them over there. One is called the valley creeper rafter. Okay, that's that little piece of rafter that goes down to the roof. And then the pitch plate. Okay, or the Dutch something. I've just heard it. I just know it by pitching plate. Okay, where they lay a board across those other rafters in order for the rafters of the roof to come down and hit them, have some place to hit. Mm-hmm. Mm-hmm. This is how, instead of drawing diagrams, I'll be presenting a lot of the questions. Okay? There'll be a diagram there. There'll be A, B, C, D. Then you have to tell me what those components are. Yes, ma'am?
Okay, so you have like will the answers still be like in the same position? Does that make sense?
There will be an A and then a blank out beside it where you're going to type what
Will it
A.
be the same like on the review than the test, or is it going to be all mixed up? Does that make sense?
It shouldn't be, it's going to be pretty close. I won't guarantee that it's going to be identical, but it'll be pretty close. Okay. But don't learn the name, not the letter. Okay. Learn that that's called a hip rafter, right? Yes. Pardon me?
Will there be a word bank on the test?
Will there be a word bank on the test? No. There'll be a word bank on your 4x6 card. Now, there are some questions that are called jumbles, where you have to choose to fill in the blank through, there's about 2 or 3 of those, where you do have But there won't be a word bank, okay? That's why the 4x6 card, okay? Make use of it. Learn how to write small legibly. Okay. Okay? Truss. You should know those components, okay? What those components are. You should be able to label that drawing. That drawing will be on the exam. That diagram will be on the exam. Okay. And then roof framing, okay? What is A pointing to? It's kind of hard to see, but what is A pointing to? It's supposed to be the sheathing. It's not doing a very good job, but or decking, okay? I'll accept either word, either sheathing or decking. Roof sheathing or roof decking. Yes, ma'am?
I still have a question about the note cards. Can we put whatever we want on it?
Yeah, anything. As long as you handwrite it, okay? Yes, you can draw on it. You can do anything. You can put whatever. You can put, what you had for dinner last night, if you want to, or whatever. I don't care what you put on it. You will turn them in. Okay, you will turn them in at the end of the exam. Okay, before you leave, we will take them up. Okay, they cannot be larger than 4x6. Okay. If we see you using a card that is larger than 4x6, we will come over and take it out of your hand, okay? And you will not get it back, okay? So 4x6, okay? It needs to be cut to that size. Don't take a piece of paper and fold it to that size. Get your scissors out, get your mat knife out, or whatever, cut it to that size, okay? It can be a piece of paper. It can actually be a 4x6 note card. That's a standard note card, right? 4x6. Mm-hmm. Yeah, and you can write as small as you want to. Okay, you cannot bring a magnifying glass though. That card is the only thing, along with your computer, that you can have on the desk. Okay, that's the only thing that will be on your desk. You don't need a calculator. We're not going to crunch numbers, okay? You should know what these components are, right? This is the fascia board, right? There's rafter. What's this right here? What's that board right there? Yeah, ceiling joints, okay? I want you to be able to understand three-dimensionally where these pieces are in the building, okay, and how they go together, okay, so that you can identify them when somebody cuts a section through the building. You can look at the section and go, that's a joist, that's a rim board, okay, that's sheathing, okay? You know where those things are in that building, so you can read it. You can read the layers, okay, and it's going to get more layers as we get to the envelope. We're going to have another whole layer of layers, waterproofing, shingles, all those things that are part of the envelope system. Okay, that's the last slide right there. Okay. Any last minute questions? Any last minute questions? Well, you've got till next Wednesday. You can ask them during class. Okay. I'll have that test exam out tomorrow morning sometime. Then sometime over the weekend, I recommend you download the lockdown browser and take that test.